Hello everyone, my name is Henk-Jan Zwolle and I'm a member of the Competitive Commission and I have the honor to introduce the speakers of the last session of this virtual World Rowing Coaches Conference. Today we have two presentations. The first is about rigging and the second is about exercise testing. The session on practical rigging boats is presented by Gianni Postiglione and Conny Draper. Gianni is World Rowing Development Director and a very experienced international coach. He has successfully set up high-performance rowing programs in Greece and Lithuania and is helping many other countries to do the same. Conny is world famous for her biomechanical skills and knowledge. She is applied sports biomechanist and has done her PhD in Sydney. She has worked in several countries at school and national team level. The second session is about performance testing. The need for relevant testing is obvious, but not every team has access to exercise physiologists or laboratories, nor the funding to do the ideal test to obtain every detail of each athlete's performance indicator. Ibtissem and Sabhi will explain what other low-cost and high-capacity testing they use to get useful and information of their rowers. Ibtissem Trimech is coach of the Tunisian junior team under 16. She's highly educated in sports and rowing in particular, and she has done her education in Lausanne and at the University of Hertfordshire in London. As an athlete, she won several medals in a variety of national and international regattas in a single and lightweight single in the years between 1999 and 2015. As a coach, she has been successful with the Tunisian team at the Arabic and African Championships in 2017. The second part of the presentation will be presented by Sabhi Khardeni. Sabhi is professor of sports. As a rower, he was successful in the single as a junior in 2000 to 2001, and as a senior, he has qualified for the 2008 Olympics in Beijing. As a coach, he has been successful with the Tunisian team, qualifying for the Youth Olympic Games in 2014 and the Olympic Games in Rio. His lightweight double sculls is qualified for the Olympic Games in Tokyo. He's also coach of the coastal team, so he has many traits. Ibtissem, the floor is yours.
Hello to all. Thank you very much, Rosie and the Competitive Commission, to invite me for this rigging session. We start immediately with our target. What is the rigging of a boat? First of all, we should know that rowing requires a synchronized movement between the rower, the boat, and the oars. Rigging is an empirical activity based on common sense principles and experience considerations that are choosing a boat with the right sides related to the average of the crew, applying the measurements on the body sides, power and mobility of the rower, applying the speed related to the boat category in which you intend to compete, and choose blades with the appropriate lengths, spoon, sides, and elbow sides. So everything must be done for the rowers and for the technique that we want to use it. First of all, we should see from a FISA point of view how we can look and how we can understand what is the boat and which point we are referring when we use some terms. The bow is the front part of the boat, is the part that will cross the finish line before. And then we have in the order the rowers. In the position closer to the bow, we have the rower number 1, and this name can be also bowman or bowwoman. And then in front of him, it will be the position number 2 or stroke. And this is the position of the rower that is taking the rhythm and he take the strategy of the competition. In the bottom of the boat, we have the stern, where we have the reference point for the direction. These are the points that are important when we speak about competitions or races. These are the main reference we use it. What we have behind this? We have one boat that is made by other components. These components, now you see like one explosion is extracted from the boat. The main components of the boat are the sliding seat, where the rover is moving up and down, the slide, where the seat is moving up and down in the boat, and then the deck, where the slides and the seat sliding are fixed on the boat. And then we have the full stretcher, where the fixed, very safety, they are fixed at the feet. And then we have the riggers that are this pattern. These are especially wing riggers. The wing riggers are connected with the hull of boat on the SAX board, that is the connection between the deck and the wing riggers in this case. We have a different form of hull of a boat, mostly are two. And one is the U shape that is quite flat and is like surfing on the waves and on the water. And we have another one that is V shape, that is a little bit more thin and is more penetrating in the water. These two kind of shape of hulls, they have different, to say, feedback on the rovers. The rovers, many rovers, they like the flat of the U shape because they feel more stable the boat and they feel the boat nicely under them, and the boat accept also some mistakes. But the V shape that for name is more fast because it cut the water and with high speed try to move up from the water. This kind of boat is a little bit more difficult because for this very narrow part of its profile in the water create more difficulty for the balance. Of course, on this boat, must rowers with a good feeling, with the good balance. In rowing, we have a little bit of the history in this picture, a history about the riggers. For more or less more than 100 years, 150 years, mostly the riggers, there was only this, in different material, mostly metal, very light, like aluminum. The rigger from aluminum in the last 20 years changed, start to be wing riggers. And with one stage of between the aluminum and wing with the carbon tube riggers, that they have special qualities, this carbon tube, because they were first kind of riggers, they were behind the shoulder of a rover and was very efficient for transmission of power. But now, with the modern boat, we are mostly with the wing rigger, and we have a front wing rigger. This is a front wing rigger of a sweep. We have a front wing rigger of a sculling, and we have back wing rigger of carbon, that is this color, black color. The difference between the front wing rigger and the back wing rigger is, again, the transmission is more direct to the boat, and the pin that in the wing rigger need a contrast behind with another tube is not necessary to have on the back wing rigger. So we think the final technology for rowing should be mostly on this wing back rigger. But as usual, the rowers, they have their sensitivity with the boat. They like more the wing rigger in front, eventually also with the carbon, because carbon is much lighter than aluminum. So there are the choices. Important that they have choices, and now they are quite a lot in rowing. Before to start to rig boats, we must have some tools. I advise you to buy this tool in your work box, because you will need it quite often when you want to rig one boat. First of all, the most important one, you should have 1 meter, better 2 meters for different measurements. One is the 2 meter, one tape measuring, another one from 5 meters. 5 meters because to be sure that the boat is balanced on right side and left side, sometimes we want to measure the distance from the riggers to the stern, as I will show you in some pictures later. And then we need the one angle measuring device that we put mostly on the foot stretcher to see the angle of foot stretcher where the row is rowing. And then we have the level where we can put the boat horizontal, like when it's in the water, to have the right feedback of the measurements of the different side of the boat. And then we have a different screwdriver. We have the Torx screwdriver, mostly used for the oars. And then we have the screwdriver flat, also this for the oars, but also for foot stretcher, other part of the boat. And then we have a Phillips screwdriver or star screwdriver. This is used for many screw inside the boat to fix the foot stretcher and some parts also the oar. And then we have the winches that they have different parts of the boats are with the small winches of 60 millimeters around the riggers, and we have 10 that is the most used one that is around the foot stretcher and fixing the rigger on the boat. And then we have the 13 that usually is fixing the extreme part of the swivel. And then we have the winches, the big one, 2022, with mostly with the carbon rigger boats and with aluminum tube aluminum. These are other two instruments. One is the pitch to measure the pitch of the oars or the rigger, and then we have the string plumb that is quite a primitive system, but I can tell you very exact to measure the pitch of the blade and also the perpendicularity of the pin on the boat. And then we have the stick eggs that is, especially this case here, we see there are many others too. This here is very easy, you don't need to buy, you can do yourself. I put also the measurement of this stick that is very easy to do it. And there's, from my point of view, one very good quality. When you measure the height of the rigger, this bar gives automatically the height because you put this side on the swivel, on the basement of the swivel, and then from this point to the lowest point of the seat, you can measure automatically the height, instead of to do like happen with some other systems where you should have two measurements. So we will go through and you will have the opportunity through this expo of tools on rigging. You can see also some other opportunities, and you can find very easily on international competition or also national competition in the big country where people, they sell their own product and they are very specific for rowing. Before to start to rig the boat, I always advise the coaches to prepare theoretically how to rig the boat. First of all, to rig the boat and to prepare the measurements, you should know which boat you have. On this paper, there is from the bow position, and then we have the number 2, number 3, until the number 8, that is the stroke. So the bow and the stroke, like you have seen before, are always in the extreme part of the boat, and in the middle are the other rowers, but they have only the name based on numbers. Of course, you can make also the real name of your athletes appear in this row. So before to go on with the measurement, you must know what you want to see. First of all, you must decide the height of the swivel, how much it should be. You must know the stretcher angle and how many degrees, and then the heel. Oh, sorry. The heel below the seat, how much are deep, the stretcher position, in which point it is compared with the rigger, the toes, the distance of the seat on the line of the work, and the pitch degrees. But beside this, you must know also how is the body weight of the crew that you want to use it, the height of the rowers and the ergo power to choose the spread or the span, the body weight to choose the height of the swivel, the height of the body, the power to fix the outboard and the blade pitch, and the morphology of a rover to fix the foot stretcher, if it's long legs, short legs, normal legs, short trunk, long trunk, or normal trunk, and the same with arms. Because based on these measurements of the body of the rover, you must make some adaptation on the boat, because now in the boat you can change anything you want, but it's important that you know which part you must attack when you want to rig the boat for specific rovers. So don't do like many years ago we're doing the coaches that they rig the boat based on the winning competitions. So when they win one competition, they say, okay, 158 is the winning rigging and everybody must do this rigging. This was in all the tradition, because if something works for one, it can work more for others. I can tell you also 50 years ago when I was a rover, it was also the truth, because the possibility of movement on boat was very, very few, and the boat in wood was really nice and very, very nice to see, a very good, how to say, art of work. But in reality, for readjustment to the body at that time, it was really difficult, everything. But now with the new technology and the modern oars and the modern riggers and all scientific work they are doing in the boat factory, I think now we can really make a very good job with our athletes how to rig their boats. So first of all, I see that some coaches, when they measure the boat, they don't put so much attention on this point. That is the mistake of parallax. You know, for when you watch one measurement, especially when you're watching millimeters and the roving, we always focus on millimeters, because there are many athletes, they have the feeling of millimeters. I know many athletes with the 5 millimeters of a changing or 3 or 4, they feel strange and they rove strange. Also, if they don't know, they rove strange. So there is something that is inside the brain of the athletes, understand also small difference between one side and another side, and automatically they try to adjust themselves. So I please ask all coaches to put a lot of attention on this mistake. You see, if you are exactly in line with the point that you want to measure, that in this case is 5.8 centimeters, if you are exactly, you can measure 5.8. But if your position, so your perspective is a little bit on the upper part, you don't measure 5.8, but you measure 4.7. And you know, there is a huge difference. It depends how much you go up and how much is the angle, optical angle that you have with your view. And it can happen the opposite on the other side. So imagine that from one measurement of 5.8, 3 persons, they can read one 6.9, one 4.7, and only one that is exactly perpendicular to the reading point, he can read the right measurement. And it's very often that when coaches, they don't understand where is the problem of boat, they go to measure and they find different measurement. And I understand many times I say them, oh, look, you are not working on parallax. And the parallax is the key point for to rig well the boat in millimeters. So really, you must be good specialist. When is possible to have this kind of mistake? When you measure the spread and the span, the length of oars, especially now with this big blade, is quite difficult because you never know where to put one extreme of the oar. And with the round end on the grip, also there is difficult to understand where is the end. So you should use one reference point, the wall, put against the wall of the oar and measure directly on the wall. You must find always the way to find the solution to be exact in the measurement of the oar, on the board, or the oars mostly. Then you must measure the inboard, outboard, and you see in each part of this is a 1 millimeter in the length of oar mistake, another millimeter in the inboard, another millimeter for the outboard, another millimeter for the lateral pitch and the longitudinal pitch, and the height of swivel from the seat also there. So at the end, if you don't you are not exact and you follow exact parallax, you can have all these measurements together that give suddenly something that you was not planning in your working paper that you are preparing at the beginning. So please remember the position that you put yourself to measure this the measure. The boat must be exact perpendicular. Remember, to be perpendicular, you need always 2 points of reference. And when you have 2 points in line, you know that you are perpendicular. What to do with the sides of boat? I have one general advice. First of all, the sides of boat depends from the weight of the rovers. And with the weight of rovers, you must always understand that the bigger boat are not just wider boat, but also longer boat. Now, if you go in the main manufacturer of boats, you see that they have for one double, 3, 4, 5 different kind of mold, because in each one there is a lightweight man, lightweight woman, senior man, senior woman, heavyweight, depends from the size. So you have a very big possibility of choice. Of course, you don't need for every kilo of average is going too high, you need to buy a new boat. There is a kind of to say elasticity in the use of boat, and now all factory they give indication from one boat that is inside 10 kilos. So you can find one boat that is 65, 75 kilos. So the coaches, they know that in this area, they have the boats for lightweights men and also some senior women. The boats that are from 63 to 70 are mostly boats for women, also lightweights. And of course, these boats are much shorter because they don't need big surface for such a low weight. And then we have the boats for men that are quite long, and we see that also 1/8 can be 17 meters and 17 meters and 700 centimeters, 70 centimeters. So they are really big length, and the technology for the material used for this boat is really on the top. And imagine the torsion effect that they can have 8 stronger over, maybe like in this picture here, which effect they can have on the boat. And of course, these people so big, they need one boat that is exactly for them. One way to understand if the boat is adapted for the rovers is this one, that you measure the height of the rig from the water. There are 2 systems that I put here. One, I think you understand what this means. And this is the oar, this is the rigger, the tube, aluminum tube, like I said before. This is the seat, full stretcher, and the rigger. Here we have the swivel with oar inside. Of course, if you want to measure the height, you should remove the oar from the swivel and keep the boat in balance with one level up here. And then you have the measurements of with the boat in balance from the swivel going down, or in 1 cup of coffee, this plastic one, or you can put 1 piece of wooden floating on the water, both of them, and you measure from the bottom. I think the cup of coffee is much better because really do not have any influence also from the waves. But when the piece of wood always is moving up and down, I think the plastic glass of water can work in very good way. Of course, better don't use 1 day of waves because you will not have any positive measurement. It must be really flat in the morning, all crews out, or before other crews they are going in the water. And the measurement of the height from the water for sculling and for sweep has to be around 26 centimeters for both of them, because now the blades are more or less all the same. And so 26 centimeters is very enough. But the height, exactly the height, is not really to have more distance from the water, but height depends mostly from the sides of the trunk of the athletes, how much it is when it's sitting on the boat, and which effect he has when he want to row, which kind of movement we should see when he rows. So this is what I said as for from the distance of rigger from the water. So you put a level here, must be in level, and what we want to have. So we want to have the height of swivel from the water, and how we put the crew on the water at the pontoon. We keep the boat in level, use the plastic coffee as explained, place the end of the tape on the bottom of the cup, and then read the measurement that is up here at the center of the swivel. As I said, the standard is 26 centimeters. Now, for the rigging procedure, how to measure the boat, I made this, how to say, general table where you can have an idea of what to do when you want to rig the boat, and you can give also some priority to your work. First of all, you must, if the boat is not already fixed with the riggers on the boat, you must put the riggers on the boat. And then the first point that you should try to do it is to control the pin. If there is a lateral pitch in outward or inward, if there's a back and forward pitch, and usually can be between 6 and 0 degrees, and then the inclination of the swivel, if it's, it gives the one part of the angle of a blade, because in reality on the blade there is the pitch of the swivel and the pitch of the blade. The pitch of the blade is made by the factories. All factories of building oars, they make on your request some angles. They can be with a 0, so it's perpendicular, or 1 or 2 degrees. Also 3 if you are used, because you can have these 3 from the oar and other 3 from the swivel. But you must know before to start the other measurement how much is the angle of the swivel, because this can have an influence on the rigging that you are going to do. And then we have also the height of swivel from the seat, and then we will make the spread and the span, and then we go on the full stretcher. And you see the full stretcher, that is really one very small part, and you know, is just where you fix the feet. And we put so much attention on the full stretcher, because we measure all three-dimensional part, the angle, is how high it is, how low it is, and we make also the distance from the finish position, if it's longer, if it's shorter. So really, the full stretcher is one really important point, and we will see after why I consider all of coaches, they consider full stretcher very important for a very good technique. Then going on the oar, we have the inboard movement, that is moving the collar of blade, and this is to have two effects. One is to reduce the outboard, so reducing the outboard and increasing the inboard. This means that we will have more light pressure on the oar. If we move the collar on the rower side, so in the direction of the rower, this means that we increase the outboard, and so we are increasing the load. So if you make longer or shorter the inboard, you have more or less effect on the power that you want to express. And for outboard, of course, you increasing outboard, just outboard without moving inboard, and I will tell you how to do it. It's very simple. You make longer the oar only on the outside part instead of to move the inboard. This is one system that it can be used when there are tailwind conditions. So you maintain the feedback of the rower with the oar on his body, maintaining the same inboard, but you increase with the tailwind the outboard to give more consistency for the high speed that could have the rower, and you give less less outboard when the wind is against. But not all rowers, they adapt very fast to these conditions. Some rowers, they prefer to row with all conditions with the same rigging. And this is something, some agreement that should be done between coaches and athletes at the same time. So this is one general procedure that I think is interesting to have in your hands when you are going to prepare the boats. I want to just say one point that is here a little bit hidden in the middle of all rigging of the boat, where I say shoes down with the foot stretcher. You know very well with the young athletes that is very difficult to teach them how to move the pelvis, how to make the angle of a body to prepare the body for the catch position. And some coaches, they refer, I never use this system, but some coaches, they say, Gianni, it works very well to go down a little bit more with the foot stretcher. And they learn because, you know, the knees, the body try to stay up or try to go back compared with the pelvis because the knees are moving high high too early because they don't prepare the body. But when the foot stretch is down, they have the more how to say, they feel more easy to move in front with the pelvis. So they learn how to move the pelvis to row and to go in the catch position. So it's an advice that I give to you when you have these cases of rowers that they are not doing well with the row cover in the first part of the stroke. So we go on with the, sorry for the interruption. We go on with the position of the pin. Of course, with the inside the lateral pitch, the oarlock, pin oarlock as an adjustment or error towards the boat. Outside the lateral pitch, pin and oarlock, they can have one adjustment error toward the water. So the pin is going in the direction of the water. And the forward pin or lock as an adjustment or error for the stern, so is increasing the angle of the blade, and backward is for the reducing the angle of a blade, so we want to have the blade more in the water. This possibility inside, outside, backward, forward, they give you the idea that the pin is a three-dimensional rotation, is more or less, we say, 360 degrees. And of course, with because it's possible that he can move in all directions, we must put more very big attention before we make any measurement that the pin is in the right position. Now, which one can be the right position? Some coaches, they like to have outboard pin, so they can have, or I will show you after, like here, is here. You see, some coaches, I think the majority of coaches, they have a vertical pin, so it's 0, no angle. But some coaches, they want to have a little angle outside because they are convinced that with this angle outside, the rowers, they can have one variation of angle. If it's outside, the variation of angle is decreasing the degree from the catch. You see, this is with 1 degree outside, you can have 5 degree in the catch, 4.5 at the middle of a stroke, and 4 at the end of a stroke. I advise to all of you, also if you have a 0, if you control, because not all coaches, they control the pitch on the blades. Some coaches, they control the pitch on the swivel, and they have the pitch of the oar, especially when they are new oars. I said, okay, I have the new oar. I know how much is the pitch. They don't make any control on the blade. Some others, more traditional like me, I measure very often the blade when I see that the measurement is not good. So with the 1 degree, you can have between the catch and the finish 1 degree different. If you put 2 degrees, you have 5 and 3. So you have between the catch and the finish 2 degrees difference. Why there is this reduction? Because a compensation of the angle of the pin outside, and it creates this effect. Why some coaches they are looking for this effect? Because they don't like to see the rovers that at the end of the stroke they are washing out the blade, because many rovers to go up with the strokes, they go down fast with the hands to maintain high rhythm, and of course they introduce this mistake. To avoid this mistake, or to correct this mistake mechanically, we say mechanically because you find a kind of a trick to force them to stay in the water, there is this lateral pitch. If you think that is necessary for your athletes to make this kind of correction, to have a good movement, a horizontal movement of blade in the water, I advise to have mostly only 1 degree, not more than 1 degree, because more than 1 degree, the athletes, especially if they are not expert, they can lose the control over the blade. Now we go on the spread and span. This can have an influence on the arc of the rower. I have here one, how to say, a little bit historical point. This is the Vitruvian man, and he has been realized by the drawing of Leonardo da Vinci. Leonardo da Vinci in this picture, and this picture has been taken also by some architect, modern architect. What this means? This picture is a dimension of the man, of the human being. The human being has two main dimensions. One is the circle, that the circle is the even, and then there is one square. The square is the earth, is the ground that symbolizes the, how to say, the daily things, and God is represented in the circle. So I made one adaptation that for rowing, using this picture of Leonardo da Vinci, telling that in rowing, in reality, to have the harmony of our rowers in the boat, we need to take in consideration not just the legs and eventually the trunk, or just the height until the head. We need to take in consideration all sides of the rowers, also with the hands, because as we calculate the spread of the rowers, we need to know empirically, because no one knows exactly one relationship. Maybe some biomechanic will try to do it, but until now I have not seen any exact rigging measurement. But maybe for sure in the future with the technology will come. Now is not possible, so, but I would like to have always an idea which one should be the difference between the athletes that I put in my boat. And who knows me, this year, I have been always able to make boats with the big athletes and small athletes together. And in these three girls that you see here, they were one very tall, another one medium tall, another one small. And these rowers, they row together in training, and these two, they have done one boat with great success, and also in very short time. But you can understand from this big difference, was not easy to rig the boat for them. And, in Greece, we have a big problem to find many tall people. We don't have a huge number of people to select, to put in one boat to try who are fitting better each other. We have for the double 2 rowers, and if we have 3 rowers, the 2 they row well going double, and the third one will go in single. We don't have a possibility to change and to choose people that they have the same size, like it happened in people or in country with the big population, not only population as a citizen, but also rover population. So, and this creates a kind of this necessity to find the boat for the athlete that you have, and you must make a fast boat, especially if they want to go fast. You must find the right rigging for these athletes. So we start with these measurements to understand, for example, that in theory, this girl with this height that she has with legs, trunk, and arms, and you understand yourself that arms, they have an influence on the length of a stroke, especially at the catch, the trunk with the angle that he can have at the catch position has also an influence. The taller you are, more influence you give. And of course, the length of legs also, they have the possibility to give an influence on the cord. So for sure, this athlete has much longer cord. This one is a shorter cord, and this one much shorter. You should imagine that between these athletes and these athletes, I measure also 30 centimeters difference, 30 centimeters difference among them. And how to compensate this is something that I will try to explain now. First of all, we have the gearing ratio that is related to the wider span or spread, and also with the longer and the short oar, with the effect of increasing and reducing the arc. Now, if one athlete is shorter, and we have here one example, these are two athletes, athletes A and athletes B, both of them, they are at the catch position, and we imagine that, both of them, they have the spread, the span on this position. So they have on extreme the span. You see automatically that athletes B with the span at the extreme is like here. So he is much shorter at the catch, and of course will be also much shorter at the finish. But this maybe will be the same angle that you see at the here at the catch will be the same angle, because we want always finish together in parallel. So the expression of not parallel activity is mostly at the catch. So when these athletes is shorter at the catch compared with others, we must find a solution. And then we look at the solution. Solution is put inside the pin. So we reduce the span of this red athlete B, reduce the span, and automatically you see is more parallel and we find more connection with the same angle. And with this position inside, of course, you must also make some changes to the inboard, and you cannot have a bigger outboard, especially if this athlete is not strong like the athlete A. So we, again, with the help of technology that we have now, you can reduce the span, and we can also reduce the outboard, of course, a little bit the inboard, but we reduce the outboard to give a little bit lighter or the same feeling that he has with other oar, but working on one bigger arc. The bigger arc that in any case gives some load. Because the problem of shorter athletes with that row with the tall athletes with big length, natural big length, is that they are not able to capture the water together with them and to have the same timing in the water. So these kind of adjustments, they help quite a lot to find the connection in the boat, because when they find the connection in the boat with one decent catch angle, these athletes already with this solution, they are able to find the connection. So this is one of the suggestions, but the suggestion are others. For example, we can also act on the foot stretcher, moving the foot stretcher to have more mobility at the catch, so can extend more the athletes at the catch, and this can give also their one positive effect to increase the angle. And not to arrive in overreaching, because I never like to see overreaching, because overreaching is true that you are long together, but it's also true that to be long at the catch position, you are weak, because you are in one stretch of arms, so mostly it's the arms or body, that you cannot really be able to control. Then how we measure the spread and span. So first of all, this is one quite simple way to measure. And this, I repeat, like I said before, depends from the length of athletes, and then you decide to put the athletes, for example, in sculling, you say, I want to put 160. So 160, you need 2 persons to do this if you want to make exactly this kind of measurement. Some coaches, they are alone, they lock on the outside part of the rigger, and they block outside of the meter, and then they go on this side and they measure on inside the face of the swivel when they are alone. With this, there are 2 coaches that are measuring. Now, in this case, they say one coach put in the middle of this swivel, another coach is reading in the middle of the swivel. So you can read the exact number. And in the middle of the swivel, is only possible for this kind of rigger. You see, this is a back wing rigger, because you don't have something to put down, and the movement of the axis of the oarlock is not with the fixed point down here, but the fixed point is down here. So it can rotate around this point. So it's easy that it moves. But with the wing rigger, for example, that the base is locked down, I hope it don't move. Okay, when the base is not movable, then you can measure from down here. So you must always take in consideration that the point of a rigger that has less variation for the angle of a pin has to be there, the point of measurements. And this must be clear for all coaches. They work with the same specific boats, like where they are these 2. And you always, as I said at the beginning, we said empirical, but with some common sense principle. And this is one of the principles. Never measure at the extreme part of the pin that it can have some angles, because you can make more mistake in the measurement. But if you measure in the fixed point or your rotation point of the pin, you go always sure that the measurement is done well. Now, I want to speak with you about the inboard related to spread and the span. So what is the spread? It's the distance from the base of the pin, as I said before, or the center for the wing back riggers, to the middle line of the boat. The middle line of the boat is the lane that you can put yourself like a cable, connected with the one stripe from the bow to the stern. So you must be exactly that is in the center, because you watch with your eyes that is in line between these 2 parts. And the middle line, when crossed 90 degrees to the surface of the swivel, that is the part that you must measure for the spread. Now, when you have the spread, how you can decide how much should be the inboard? For a sweep is very simple. For many years we was doing this. It must be the spread plus 30 centimeters plus or minus 1. Plus or minus 1, it means that some coaches, they decide to have 1 centimeter more because they want to give more grip to the athletes, or they want to give them better position of arms in the finish. And minus because maybe they want to have more rotation of rovers at the catch. When they go at the catch position, they want to twist them better in the catch position. In sculling, for many years, we'll say, okay, you must have 160 and overlap 18. So then at this point, what you should do? You should do the span that is 160 should be divided for 2, and then you have the overlap that is 18, and you should divide for 2. So you should have 18 divided 2, and you have 9, and then you have 160 divided to 80, 80 plus 9, 89. I think this is really not a necessary calculation. For me, is much simple, and we are doing many years. Me and my coaches, they adopt this system, and it works very well because it's the same like in swim. You put the spread, or we say half span. So if it's 160, 80, plus 8.5. So if 8.5 don't make you happy, then you can make 9. Or if you want to make less than 8.5, you can make 8. But at this point, it's clear. And also the rovers very easily can do this. Not they must go and control the overlap. I remember when I was young coaches, and mostly I said before, like young rover, I said to my coach, I said, okay, I want to rig the boat. He said, okay, put 18. And I said, I calculate 18 should be, for example, 89 the inboard. I put 89, I have the right spread, all exact. I go to measure 22. I said, oh, it's possible, 22, should be 18. And then the reason for this is because the overlap do not give any guarantee. And the reason for this is very clear, and I will explain later to you why there are these 2 centimeters more. But if you do more simple, the 8.5 or 9 or 8 plus the inboard, you are okay. Plus the spread, you are okay. You have the inboard very easily. And then the outboard, I don't speak so much about the outboard because outboard for me must have another way of calculation. So the total length of the oar should be related mostly to the power of the outlets. So the inboard is related to the length of rovers, how much is cord, and the inboard, the spread, they go together. The outboard can change and can be measured based on the power of the rover. So rover very strong, they have a longer outboard also with the same inboard than others. Rovers more weak, they have less outboard to give them less load, but to move together with others. Here I prepare one table that is based not as usual in the measurement that should be in the boat of single, double, quadruple, the pair, the 4 and the 8, but is based on the specific boats that you want, but also related to the size of the outlets. So I put here outlets of 170 until 2 meters, and the rowers girl from 165, because we have many girls since 165 in activity, and they go even less than 65, but it counts as the principle. And then they go until 2 meters. So this is very easy, this, how to say, this calculation that you can have here. So we start from 158.5, and every 5 millimeters of height, we have 5 millimeters of spread changing. So we make a straight relationship between the height and the spread of the crew. And in sculling, so we can go from 165, one athlete's woman in single, and she can be 158.5 until the one spread of 162 for one athlete of 2 meters. So there is a common sense in this kind of proportion on the measurement. And you see that this has been done with 8.5 centimeters, but it's only to decide the inboard. The outboard, so this is not any age, there is no indication, just the height, because we want to see the spread, how much it is, and the inboard. But when we want to see the outboard, so the load, we must go in this other table. This other table say the length of the oars that they can be good for the athletes. So if they are junior or under 19, we say the oars, they can be around 287. Always there is plus or minus 1, depends from the coaches and the power of the rowers, what is better to do. And you will see how we can decide if one gear, one ratio is good or not for the rowers. And then we have 287, 288, 288 for lightweight, like 123, or we have for open 290 when our athletes for many years of experience, a lot of power, and with also experience on technique. So not only physiological capacity built in the years, but also with the technical capacity built with the experience of rowing in different boats. And the same there is for women. The women, they can go from 1 hour to 285, depends from the coaches, what they like. For them, I have seen coaches also a bit less, 285, not many, in lightweight category women. And with this measurement, they fit quite well because they want to maintain a good rhythm. You cannot give two girls of 57 kilos one huge load. They cannot find the rhythm to move fast the boat. So it's always a compensation between sides and possibility of application of the power. So I hope this table can be useful for you, and eventually you can make experiment on your own on this table, make some variation. It's just one start point, one suggestion in your project of rigging when you have one crew that you think is interesting. And it's also one idea to create boats for sites of people. For example, you can have one boat instead of to make so big every 5 millimeters. You have one boat that is for athletes from 175 to 165 to 175. So you can have one boat for every centimeter and a half. And then we have the maximum people, they have their own boat for only for 2 types of athletes. So the boat and the rigging of boat must be decided not for their strength only, but must be decided for how tall they are. This is the principle that you should apply with your rovers. Then I want to just suggest some control again in the measurements what to do. For example, if you measure the spread of the spread of a boat, don't make this mistake going down with hands, or we not calculate well where you should stay, or want to measure from the seat. Some coaches, they want to try always to say this, and they measure at here. Not because it can be wrong, because if you always use the reference, can always give one idea more or less correct. But what is wrong here, that if you are looking for one spread of, we say, 85, with this length, it will never be 85. With this, always you measure more. So in reality, to have 85, with this one, you will be much closer to the boat. So you will not have 85. Maybe you have 84, thinking that with this one is the same. So to be exact and to give the right gear to your athletes without confusion and without a negative feeling from the athletes, you must be always perpendicular and the same height of the boat until the pin. And this is an important point, because you know that what you think, what you plan, give an answer. But if you have an idea and you apply other measurement, you can have different results, and not because your thinking was wrong, because your measurement was not correct. So you must be consequent from your decision. Especially in sculling, because in sweep is a relative mistake, but in sculling it's very important to be symmetric. So you must be with the riggers, with the swivel, this is the number 2, with the same distance from this side to the center of boat, this side to the center of boat, but also this side from the extreme of the stern here, and the same time on the other side. So if these two measures, we say A and A, are correct, you know that the rigger is with equal distance from the stern, but is not sure that is the same distance from the center of the middle lane of boat. So you must always do have an extra check, making the measurement from the swivel to the rail, opposite rail where you are with the oarlock or swivel, and then with this measurement you go on the other side and you measure also on the other side. The cross of this measurement must be the same, because this is the confirmation that in perpendicular lane to the boat you have the same distance, and also with the diagonal from the stern, you are also here on the same distance. So you complete this triangle here, and when the numbers are exactly from one side to the other side, you know that your boat is rigged well. But why this rejection? Of course, it's not necessary to do this with the tube riggers, but with wing riggers is necessary, because to fix the riggers on the top of the deck, the factory, they need to have a kind of flexibility. So the riggers, they can move, not so much, not so much, 1 millimeter, 2 millimeters, but you must imagine that if here is 1 or 2 millimeters, 85 centimeters at the extreme part is not 1 millimeter, but it can be 3 or 4 millimeter or even more, depending how much it moves. So you must really be very exact. When the position is exact from distance from the boat, from the stern, you block it, and then you go to measure the rest. So you must measure between the pin of this boat, the swivel of this boat to the back swivel, and at the same time also on the other side. And then you go up until for quadruple until the Atlas number 1 that is on the bow position. I hope it's clear what we have done until here. Another issue about the height, we must have very clear in mind that what we want to obtain when we row with the height. With height, we want to have one very horizontal movement, and we want to have the arms that they go very horizontal in the finished position, so they can maintain one strong angle with arms, but at the same time they don't go too deep with the blade in the water, because you see, if the blade goes too deep, like you can see in this part of the picture, this is not so much is acceptable, but you know, if the blade is not in the right surface, you see here is a kind of break that this Atlas is doing in the water. So this blade must be avoid doing what? Rowing high. So when is high enough with ends to have one triangle and can go out clean from the water, this is the right position of the height. And you see that when he will arrive in the finish, as most of the athletes they do in the finish position, very close to the chest, he must be more or less at the beginning of the stomach. So in this position, that is the height of the finish. And then he will have the next part of exit from the water and squaring the blade. But we don't speak about technique today. We just make some touch on technique. So the height of airlock is, as I said, big influence on the horizontal movement. And you see, if the OR is too low, so the rower cannot go up well on the right lane from the catch to the finish. So we must find a way that the Atlas goes a little bit up with the swivel, and we can see not so low at the catch, but more or less near the horizontal lane. And this is what we are looking. So the angle of arms, when you rig the boat, they will tell you if the rigging is correct or not. If you see the angle of arms like this, okay, too low, you must provide for some changes, because the Atlas is not using in the right way the arms and is not making horizontal movement. Here we have other example. You see in the sculling how high they have the hands at the catch, and they are really making good position, good catch in the quadruple. Here you see another example where the Atlas, instead of, these are my Atlas in Greece, instead of to go up with ends, and then after the ends up, they go back in the drive. I want to go back, okay. So, but if you are down, for sure, when you are down here with arms and you want to go in the water, the moment of going in the water will be lifting the body, but not lifting the arms. And this is one mistake that has to be corrected together with the rigging. These are the other stick to measure the height of the riggers. As I said to you, this is quite useful. We have these two supports that they stay inside the slides of a boat where the seat is moving. And also this one has one unique movement that is to lift this stick down on the swivel. When it's down, the coach go to read and they see the measurement that he should have it. This is another one that is similar to this, but here's the feeler. The feeler is a very sensitive point that you must touch many times until it will be not will be contact, very light contact with the swivel, and then you turn it this how to call it extension over the stick. You turn it, and then you go back. You put on the center here, and you measure the height from this point that was on the swivel until the full stretcher. This difference of distance will be the height of the rigger. Now we have another issue about the oars in sculling. In sculling, beside overlap, we have another issue that is the difference of height between right and left. Of course, there is not one specific height that you should put on the boat, but for common sense and for possibility to create crews in the same environment, the national team or in the same club, you cannot teach some rowers with the left up and the right down, and vice versa, some others with the right up and the left down. So you teach all of them in the same way. And now we can say international as a value that the left is over the right. And this is the main issue. And the difference between the left tire and the right should be around from 5 millimeters until 1.5 centimeters. There are some rowers, they want to have a quite big difference. Some coach, they should say, why we don't put 3 centimeters? Because in reality, it depends from how big is the end. Especially for men, they have big ends. This can be also 1.5 centimeters. So it's not 1.5 centimeters like here, but it's 3 centimeters. But this is not the parameter to have it, because also with athletes with more centimeters, I've seen that, especially in the finish, they don't have a good finish because so much difference. They go too much down, and they wash out with mostly with the right hand, all the time. So the best way is to cross and to finish the ends on the same height. And the standard date, so the difference is between 0.5 and 1.5. The standard date is 17 centimeters, and this can be plus or minus 2, because minus 2 is for girls, for lightweights, with the people tall, a small body, and also with the smaller boats. So these athletes, they can have 17 plus or minus 2. They will be mostly on 15. In some cases also 14 when they are very light girls. And the right will be 1 centimeter less. So the average of the standard measurement is 17, 16. 17 left and 16 right with 1 centimeter difference. In the lowest extreme, you can have 15 and 14. And in the highest, it can be 19 and 18. In the sweep is also here, the height is very easy because you can find the height that is 17 centimeters, mostly for all. Okay, this, left and right do not exist. Left and right is sweep. This is a mistake down here. And will be only 17 in the sweep, and this is 17 plus or minus cover all range of athletes that they will put this measurement. Of course, this is, I repeat again, is a start point, because then you must observe what you have put in the boat. It's not just 100% of confidence in the number. Please don't do this mistake. Oh, the number are correct. The number they are correct, but if the rover he do not fit well and he has some mistakes, he produces mistakes for the rigging, the boat must be changed and adjusted to a little bit more to the rover. So they are starting point of rigging. Then daily, in a short time, will be possible to fix it well and the boat will be perfect for this rover. Then we have, as I said before, all changes that we can have on the full stretcher and the effect that can have it. You see, here I put how to change the full stretcher and what we want. For example, with the stretcher angle, we have one angle that can be between 40 and 45 degrees. So this is the, okay, this is the minimum angle that you can have it. So we call it quite flat full stretcher. And this is the maximum. When you have 45, that is the maximum angle of full stretcher. What is the difference between these two? With the 40 degrees, you can have better compression at the catch, but when this rover that compress well the catch and can be also more active with the legs. First of all, you don't transfer of power on the full stretcher because the angle is pressing the boat in the water, pressing the full stretcher in the water. But when he's in the finish, he is like a swimmer. He has the feet in extension, and we don't want to have the feet in extension, but we want to have, in this case, the feet they are pressing with the heels on the boat, not with the upper part of the feet. So this is something that is coming out from the angle of full stretcher. So mobility at the catch, facility to rotate on the pelvis to make a longer stroke. But if you have 45 degrees in the finish, this is the most point, because with the 45 in the finish, the legs are pressing well on the full stretcher, so the athletes, they are able to have this measurement, they can make really good pressure at the end of the stroke. About the depth of the shoes from the seat. This is another point that give the possibility of mobility mostly at the catch, because if the shoes are quite low, the knees are down, and it's possible for the rover to make a big angle in front with the body to make a longer stroke. But if the knees are too low and the rover is falling down all the time at the catch, instead of to put the brain in the water, it's going down. So in this case, you must ask to go up with the full stretcher to control this losing of position of body at the catch that he was doing before, and he must adjust himself, adopting the right angle of full stretcher. The best position for full stretcher at the catch is to have the knees under the arms, but very close, mostly touching the arms. This is the best position, not too low and not too high. Sometimes they are touching the neck. Is not good to have it. And then this is another point, the distance from the swivel. So the swivel is this, and the distance from the swivel is the position of finish, is from the swivel here until the middle of the seat. This is distance that can be from 60 to 56 centimeters, the middle of the seat. So from here to here, there are other 4 centimeters. This will give the exact finishing point for all crews. And when you have this finish point common for all athletes, for sure these athletes have better balance. They put the blade in the water, but they exit from the water together, of course, with plus or minus 1. And then they have a better feeling and they have more balance, because when the rovers exit from the water together, the balance is much better and they feel that they control their movement. But if so I don't give any indication where to put here in front. For me, I said put 57. put 58, put 60, put 61. Any measurement you put here, this has only to be executed. The others, they arrive here. But there is also another method to have. 57 must be from here until the center of the seat. There is another method that we know how much it is, this position 56 or 57 from the rigger, and we put one tape on the deck of a boat, and then from this point of a deck of a boat, where is the projection of pin, you should know that there is also the working point. Some factory, they put working point. They mark very strongly this point. That is the middle point of the working area of the athletes. This working area of the athletes is between 140, 145, 130. This is for from lightweights to seniors. When you give the 50%, as given by the factory, the 50%, then you can decide how much angle you want to go at the catch, how much angle you want to go in the finish. So you make specific adjustments from the needs of your athletes, and again for his flexibility and his capacity to adjust himself to a new technique and a new position. And then this is what the point important that we have with the foot stretcher, because with the foot stretcher we will really decide which one is the technique of the athletes, and mostly for the position of the knees, and not only at the catch but also in the finish, because you see now the manufacturer, they are changing a little bit, especially in the single, but this kind of finish position is not really positive for the athletes, because in single the boat is very narrow, there is no space, so also the movement of legs is very, very tight, and the athletes are really compressed in this boat. If we put this deck here too high, the athletes, they cannot stand the legs, because when they arrive there, there is an obstacle appear. This obstacle, they must be eliminated in two ways: or buying a new boat where it's not, but this is very expensive, or putting on here one pillow that you put the rower higher, and with the rower higher, he can press down with the legs, but he has not so big damage on his gastrocnemius when he's pressing at the end, or other problem that can come out from the kind of pressure of legs on the boat. So this is another issue, and we have here okay, about the tracks that we put on the boat. The tracks should be a kind of control for what I said just now, because it's true that manufacturers, they try to reduce reduce the height of this deck. They want to make lower the deck. They are trying well, and they have done it. I have seen it, but the old boat is not possible. When it's not possible, you must increase the height, putting pillows here. And the pillows here, of course, reduce the feeling of balance, but this is one issue that has to be adapted. And why not? It can be also something positive, because it's better to have the possibility to extend your legs, expressing maximum your power, and learning another stage of balance. Then we go on the OR. And this is one of the issues that is pending from many years. Which kind of OR is important that we should choose? One very rigid, strong OR, one shorter, a little bit more flexible OR. Which one is the best one that we should use it? First of all, with OR that we choose, this can be only done in training. But when we put the OR, to be sure that it's working well, we must measure the pitch of blade this time. The pitch of blade is the angle that is coming when you put the blade on the oarlock, and the blade has one angle because the request of a customer to the factory said, I want to have with the 1 to a degree, and they ask with this degree, and they get it with the same, with the degree requested. But when they have this degree, they must control that on the blade, they don't have too much angle or less angle. So with the plomb or with the one pitch meter like this one, we put on the blade mostly a 7 or 8 millimeter from the extreme point. When we put this reference point to measure, we measure and we see how many are the degrees. For sweep and sculling, that is the same. Maybe it can be 1 degree less for the sweep. We can have around 4 or 5 degrees. We can find also over 4 degrees, but it's nothing that you should be crazy for going down with the millimeters. I think it's more important. Sometimes I increase the pitch because I want the athletes, they feel they are moving in the boat, not the oar is moving them because it's going too deep. And this is one of the example that I think is interesting, and I connect what I said to you at the beginning, why we have 2 centimeters more with overlap, and for me make not trustable the overlap. So here in this picture at the beginning, we have the ratio that we should have in the boat. The ratio is done by the outboard, that is this part, so the total length, less the inboard, give the outboard. And with the inboard, we have from the extreme of inside of the collar that goes on the contact with the swivel to the extreme of the oar. This is the inboard. How is the ratio? Very simple. Is the length of the outboard divided the length of the inboard. And this will give 1%. This percentage is very easy to understand. And you can find also on the website of the blog site of Valery Kreshnev. He said, put me the measurement, I will tell you how much is the degree and the value that is this rigging that you are giving to the boat. So this is another point. To have a better calculation, first of all, we should understand how the ratio is done with the new blades. Because you see in these years, from big blade was the beginning, we have a smoothie, and then we have vortex edge. Now we have also 32, and all this they have some increasing of surface of a blade, some other reduction. In I think quite intelligent way, concept when increase the surface of a blade. He don't say now you must change the gear of your boat. Automatically, it's more surface, and they make the oars shorter. So this is, in his opinion, he should not know the surface of a blade because it's already calculated in these centimeters that you reduce. So I think the last oars is 5 centimeters. If you reduce 5 centimeters, with 5 centimeters less, you can understand immediately if the gear and the ratio is correct. I am not so agree on this point. I am agree on the less shaft to give a good feeling about the pressure of a blade, and must be because always you increase the surface and you maintain the shaft always the same. The oars so heavier and heavier until you reject the oars with the big blade. So this has to be done. But this can be done also making other calculations. For example, when we make the inboard and outboard, what's happened here? You see, the inboard is until here, but is not calculated to go on the center of the pin because the center of the pin is occupied by the sides of the swivel because the swivel is not very thin. The swivel is not a tube. The swivel is one surface quite big that is 4 centimeters wide. So to have the idea of the inboard that is overestimate because it is more than what you want to have. It should add to have the inboard. You should add 2 centimeters. When you want to measure the outboard that should be longer in reality is not arriving at the middle, but is arriving inside the door lock. So, for example, for the outboard in this case is overestimate, because always we cut 2 centimeters from the outboard for the ratio that they should be calculated, but we don't calculate because they are not effective working. But we have a lot there as a measurement. So the spread in this case with the spread with the ratio with outboard, deducting from the outboard 2 centimeters, so to give the real outboard, divided the spread is the measurement that you want, because the spread is the middle or distance, so the distance from the pin until the medium lane of the boat, and we make plus the inboard. Sorry, we don't make any plus inboard. We just make this that is at the pin, from the pin to the middle distance, exact, and then this divided for the inboard. And this gives exactly the gear, the ratio of the wire that you have. You should make a little bit careful when you have oars with the bigger sides, with the big pressure in the water, and the shorter, because in this case you cannot compare the ratio of these oars that you will have the ratio before with the rover longer, with the oar longer, because the ratio with the one longer oar has an influence with the length of oar, so 6 centimeters, 4 centimeters. But the oar short is not because it's short, because its pressure point is more extreme. So in reality, it's at the same distance like in the other boat, in the other oar. So you should not deduct the 2 centimeters, the 4 or 5, 6 centimeters when the factory said, but you should really add there and maintain it like a kind of compensation. Okay, here we have the next stage. Now we finished our boat, we rigged the boat, we think that is correct, but we cannot say that is correct until we don't see what's happened. So we have, first of all, 3 situations. The first one, the boat is rigged, they go on the water. You are as a coach near the pontoon, the athletes are in front of you, and you ask them to square the blade perpendicular going in the water and maintain the blade just under the surface. With this position under the surface, you see where are going the ends in the finish and how much are opening the end in the finish. Because when the legs are extended, the body is perpendicular, you can observe this, the dip and also the distance in the chest. Now I make these pictures, I put this picture that I find it, and these are 3 positions. One is very wide or very open, and this is not good. This is very tight. The athletes are really, the ends are really close each other. You can have a problem also with the fingers. So, and this is not good. The first one is the good one because he finished well. He has right, the arms quite high in the finish. And at the same time, he has quite a good space at the center. This is the key point of what to do. And you must be always in front of the athletes. You cannot be beside, because if you are beside, you don't see these changes of difference. You cannot have the perception. You can understand some mistakes or some adjustment that must be done just going in the right position. If you stay in another position, you don't see nothing, and then you don't make correction to your cruise. Second observation that has to be done is when the rover, they row continuously and they make kilometers. So if the rover, they go continuously and they are passing near you. So in this case, they are in front of you, but they give you their side. So when you watch their side, you must see the height of the ends and the blade. So with your view, we must check blade where is and ends where they are. If you go, you see the ends are going down and the blade out, this is a mistake. So the rigger is too high. Or you see if they change the posture. So sometimes when the riggers are high, athletes, they stay high with the riggers because they are fresh. When they start to feel tired, they go down. And when they go down, they learn a mistake. And they can have not really the right technique for the future. Or some coaches, they see that athletes are going down and down in the body. Instead of to correct their position of body, they say to the athletes, okay, put lower the rigger. And then we have the last and you measure the gear, the ratio of gear in the training, only when you see that the athletes for 1 hour, 1 hour 15, 1 hour and a half, you calculate the limit of your preparation. When you are in this time, you see the athlete very, very tired. He cannot move. He has difficulties to continue with the same rhythm, and you see that he starts to change the posture. He goes back with pelvis, to make a big curve over the back. So when you see these changes, or you change the gear for next training, or you reduce the training until the athlete is not fit enough to work well. And then there is a last one of the race. You have in the race, you must see if the gear is good based on 3 things. One is the start, one is the pace race, and one is the variation of speed at the end of the race. So if you see that the start is good, the first strokes, the athletes, they move well, this means the gear is good because they are compact and they move well the boat at the beginning. If when they go in pace race and they are forced to stay 1 or 2 strokes more because they cannot stay with other opponents, you understand that the ratio is too light, the gear is too light. They must have a little bit heavier gear. So in this case, you study with between one race and another race. So it's better to do the race in training before to make an official race to send the athletes well prepared. And these are the 3 observations that say to you that the rigging is correct, that you are in the right way, or you see that something has to be changed. Of course, there is the last, how to say, activity that you must do with the rigging is to speak with athletes and ask their feeling, because also their feeling is important when they row. They must give you the feedback of what they feel, because first, it's important that they express themselves, but also because they start to think what to say to you. And this is also another good example to teach the athletes to be good. I finished my explanation. I want to thank you very much, Rosie McLaughlin, because she has made a very good book on rigging and technique, and was very helpful with me for me. And I think many of the issues here are coming from her book, as well with the Chris Kozenioski, that is Coach Educational Program of USA, is one of the best coaches in the world, and he has been successful in all countries, and we work together some years in Italy, and he helps me also a lot in rigging. He has been always good in rigging. He's an engineer. I thank the Greek team that cooperate with me in these difficult days, as well the boat builder Filippi, Cantiere Filippi, that they give a lot of pictures and their support to prepare this material. I hope that everything has been useful. And I give the word to my colleague Conny that is coming after me. So thank you very much, and I hope to see you soon.
I'd like to continue with the second part of the practical boat rigging session. Gianni talked at the end about the oar gearing. I would like to continue to talk about the setup of the arc lengths we are aiming for with the absolute catch and finish angles we want to set our athletes up. Obviously, the idea of the rigging setup is that we try to align our crew members by the angles, and that they are in time with each other throughout the drive and also the recovery time. The rigging is obviously very depending on the boat category, the level of the rowing, the gender comes in, also the boat classes. I did put in the table here so you see the ranges we are going through with the stroke length, the catch and the finish angles in the sweep and sculling categories. And you can here also see sort of the differences between novice rowers up to experienced and elite rowers. The ranges within the stroke length, the catch angles and the finish angles look quite big. The reason for that is that the numbers include the recommendations from the lightweight women's categories up to the heavy men's categories. So that's why you see quite a big range of sometimes more than 10 degrees within the stroke lengths, for example. So, but obviously you know about some lookup tables, or in any of your previous rigging sessions, you would have had access to more precise rigging setups that we sort of aim for empirically and that work well within these certain categories. So obviously in the beginning we set up the boat. Once we've done that and our rowers go out on the water, we do know and expected that they actually will come back, and we will see it visually that often further adjustments will have to be made again through maybe the oar gearing, or most likely through the foot stretcher positioning adjustment that sometimes also comes with a slight adjustment. We should never forget that athletes are also capable of changing techniques, so we don't constantly need to change always that mechanical rig. All athletes also obviously can able to try to fit in within the crew by working on their technique and their awareness throughout the stroke. I displayed here 2 examples of how to set up the arc lengths with the absolute catch and finish positions. There is the method, the reach distance method, that requires the inboard lengths for the targeted catch and finish angle we are after. And the other method would be one where we require the spread distance length for the required catch and finish angles. Of course, catch and finish angles, adding them up gives us the total arc our rowers work through within the drive phase. Going back to the spread distance method, you can calculate it for yourself. So the formula is underneath there, or you can also find lookup tables if this is easier for you. So I just have one example here where you see for a sweep example that we are aiming for a total arc length of 90 degrees with a catch angle of 50 or minus 58 degrees in front of the pin and 33 degrees behind the pin. The spread from the pin to the midline is 84 centimeters. Now, using our lookup table, you go to the 84 centimeters, look up the targeted catch angle. So we would have to move, or we need to, the number of 134.4 centimeters to go from our perpendicular pin line towards the stern on the midline. So you find your point where the angle is minus 58 degrees, with the second string using it from the pin and then intersecting with the midline. You can now mark your catch angle position that would be on 58 degrees in front of the pin, and then you repeat that method for the finish angle. In this case, for an angle of 33 degrees, we have to move from the from the pin line over the mid line 54.6 centimeters towards the bow. So that gives us 2 points. Obviously, most coaches would use a little bit of sticky tape or a pen to mark the 2 points visually for them. If you also like to give your athlete visual feedback, you can add little straws that gives them a little bit of feedback in what range you want them to work at. If you prefer the other method where you use the inboard, the lookup table works exactly the same. In this case, you look up your inboard, look for your required catch angle, in this case 81 centimeters. Now we do it slightly differently. We go from the perpendicular pin line along that midline 81 centimeters towards the stern. Now we mark that point. Here you will need another ruler or a sort of a rigid stick, so you can mark accurately the point where at the end of your inboard, so on the handle, the point, the intersection point of the shoulder and the midline line up perpendicularly to that midline range. Again, you can mark your point for the targeted catch at the shoulder with a pen, sticky tape, or visually also with a straw. So there are a lot of options how you can set up your boat initially, and once you've done it once, obviously you continue to do that for the rest of the crew members in the boat. Once you've done the setup of the oars and setting the catch and finish angles in the boat, obviously then we also have to move towards the foot stretcher to look at the setup there and what is required for your athletes in regards to stretcher angle, then shoe height or heel depth, depend how you like to name it. Then obviously the placement of the stretcher in relation to the pin and the seat, and an important point is also the shoe size. The foot stretcher setup is highly important for the required posture we are after for the athlete. And there's always that sort of great image I like to use of Kim Brennan, who had not just the anthropometry, but also the strength and that awareness of what posture is required to be able to have that free, effective, and comfortable movement, to be able to reach a long catch angle, to coordinate your blade placement in tune with the beginning of the leg drive, and with that sort of solid catch position, being able to initiate and execute this a strong, effective leg drive. Yeah. However, we are all aware that the setup of the stretcher can become quite individual once you look into the different anthropometry, mobility of the ankle and hip flexibilities of the different athletes. Also, their different strengths level comes into account. The other one, obviously, shoe size and the technique the athletes already are sort of incapable of executing. So again, with the foot stretchers, there are these different points we already touched on. So they are obviously for the areas of the points we can adjust on the stretcher. There are also recommendations that, you know, has come out empirically over the years. So when we look again at the stretcher angle, obviously you find in the recommendations 40 to 45 degrees stretcher angle. Idea would be going a little bit sort of steeper, 42 to 45. However, we have quite a few athletes who find that still too steep for their mobility in their ankles and hips, so it also being capable of rocking over. So we have quite a lot of them who stay more around the 40 to 41 degree arc. So again, then you can also try to compensate that a little bit with the stretcher height. Again, there the range looks very wide, but obviously this is for the different boat categories from lightweight women up to heavyweight men, and the different shoe sizes come into account here as well. But stretcher height, again, also is quite individual within these different categories of lightweight, heavyweight, women and men, but also, and we should not underestimate it, like the leg ratio of lower upper leg comes into account here, and as mentioned before, the body type and the mobility of our athletes' joints. Stretcher position, I guess pretty straightforward. The most coaches sort of set up their athletes with a stretcher position that they first look into the distance between the pin to the seat at the finish position and aim for 56 to 60 centimeters. And then depending on your leg length, you set your stretcher. So again, that is quite different. Something our athletes can change easily once they sit in the boat. That's a good, that's an advantage in our rowing boats. Then the next point, what is displayed here, is obviously shoe widths, but more in the way of how far apart are the shoes from each other. This is mostly depending on the boats they sit in, because our singles are quite narrow. So the shoe width we can reach there is around 13 degrees, which is very narrow for a lot of athletes. And we do see that a lot of them then struggle to keep their knees and legs parallel. Once they go into the wider boats, the displacement between the two shoes widens out and goes up to 18-20 centimeters. So that's of course depending on the boat, but it's also for the comfort and the ability for the athlete to work through the legs. We should actually make sure that athletes feel quite comfortable and are more aligned from their hips down to the feet, so that we get their full potential of the leg drive through the stretcher. Again, on that picture, you can also see that the feet have a bit of a splay on the shoe plate, so the splay can be changed slightly, and further developments that are coming up or has been used already. They also give you sometimes an option that you have more like a floating shoe. It's depend, as some athletes really like it, some prefer that rigid feeling of the shoes at a particular angle. Again, that can differ in relation to the flexibility and mobility of your ankle, knee to the hips. The next point we thought we like to just bring up here is the different stretcher systems. Obviously, the standard one everyone is familiar with. So we have the typical flat board with the adjustable shoe plate that gets attached to it. You can see here in that example already that there is, so where we attach our shoes, you can also move a little bit the splay for the shoes. So this is something that will become more available more and more these days. When we go into the other two systems, like the BadLogic idea and the Shimano idea, BadLogic brought out their system, their shim system, that sort of had the idea to allow the athletes to have that improved foot support and a greater engagement and enhanced heel load through the whole stroke. Another good side effect of this one is that it came with sort of the personal shoes. So from a hygienic point, of course, that's great. Athletes and coaches who like that system, they like the idea of feeling a very strong, solid contact to the stretcher in the way of, you know, keeping balanced well through the feet there. The Shimano system has a totally different view there. So it uses a pivot, which helps to give athletes the option of reaching further towards the catch. The first version of that system was not that easy to attach into the boat. So we haven't seen that many Shimano systems around. But they also have changed already their idea a little bit. So now it looks a little bit more like the standard system, but they do keep their idea of that pivot where you attach your shoes to with a quick release system. So you can still reach the pivot towards the catch if you like that feeling. So all three systems obviously work well for different type of athletes. You just have to figure out which one works best for you to be able to execute a strong stroke through the rowing cycle. Another big topic is always blade shapes. Obviously, the effect of the vortex is always an interesting discussion point. When you look at the standard blade versus the vortex blade, you can see visually straight away a big difference. Whilst the standard blades are a bit bigger in their surface and they aim for a strong connection at the catch and at the finish, you see that the vortex blade is differently cut. Their aim is here to decrease the slip in the first half of the drive, which in turn increases the resistance and efficiency. This type of blade is used quite a bit and liked by athletes who row in bigger boats, because the emphasis is more on the catch and the early part of the drive phase. That particular vortex blade also has a sort of increased slip in the last quarter of the drive, which then again is not that important for the bigger boats, but it would be important to stay connected through the smaller boats. So that's why we still see a wide range of blade shapes used. So not one fits all. So there is a variety for different boats and for the way you coach your athletes that finds the appropriate blade for the technique you're after. So rigging as its topic is highly comprehensive, as we could see, and as you would discuss with many of your colleagues and also with the athletes. I guess it has challenges and it has huge opportunities of what we can do with rigging. So the challenges, the one-size-fits-all setup is that is of course hard to do it in different ways in big clubs, universities, or schools. Yeah, the boats have already standard setups and they share boats, so it's hard to make lots of changes. On top of that, you have big squads in these clubs, and there's always that time issue that you run on a very tight timing schedule. So it's very difficult to try to change for the individual the spans or the oar gearing, the stretcher setup, and the seats, or to the grips. Yeah, so there are a lot of points where you will not make everyone happy in the boat. I think one of the biggest problems I often see when I work with sort of within the environment of clubs and universities and schools is that a lot of smaller athletes have to hop into the given shoe size that is in, that can be far too big. I've seen easily athletes rowing with shoe sizes that can be 6 sizes too big. So can we accommodate something like that? So that's something maybe we can think a little bit forward going into the session of how we seat our athletes and what we can do to give them the best possible setup in the boat. However, on the other hand, as rigging has its challenges, it has also huge opportunities of getting our athlete into positions that will assist them to improve their technique and training quality, and with it the big aim of improving boat performance and faster speed would come from that. So anything in oar load gearing, as much as we can set that up individually, is going to assist your athlete to perform the work through the stroke better. The same with the grip. Yeah, if we have a better grip for the hand conditions we have and the hand sizes, that would always be a little add-on towards optimized technique. Seat is a huge opportunity that has been a big issue, but also is on the way to become much more individualized, because we have noticed a lot of issues, especially with lightweight rowers and women that they were in a lot of pain sitting too long on a seat that was not shaped for the hip structure they have. So we should not underestimate the opportunities we have by getting our athletes comfortable in the boat where they get locked in during the training sessions. The more comfortable they are, the better they are set up, the better they can perform. And that would be the same with when we think about shoes and also the stretchers setup as mentioned before. Emphasizing on that a little bit again and just going through the catch position here is I just want to show you the aim of what we are trying to achieve through the rigging, that we can assist athletes to get the best possible work done per stroke, and that means to have a very long stroke length from the catch to the finish, very effective in the way that there is hardly any slip at the beginning of the drive phase, and also a very strong connection through towards the release of the blade. So if we can achieve that with our athlete, we need to make sure that in return we assist our athlete to find the best possible setup for them to perform at that level, but they do need for that an individual setup that suits their requirements in regards to their anthropometry, in regards to their skill level, and also their strength level. So when we aim for a catch where we know that a catch position as sort of pointed out here on the left, with the heels slightly off, shins vertical, pelvis slightly over, spine neutral, that will really assist the athlete to fine-tune the blade placement with the initiation of the leg drive perfectly. So to start that leg drive, be able to hang, and then, as seen here in the force profile, to really sequence properly our major muscle groups, legs, upper body, and arms together. If our athletes cannot find that position for the at the catch, then what we often see then in the force profile are shapes of force curves that indicate some kind of catch slips. This pretty much means that with the setup they have, they often find it hard to fine-tune that sequence of connecting properly at the catch and sort of timing and synchronizing the blade placement with the leg drive initiation together. And then you can see that the shapes of the force profile show us technical difficulties early in the first half of the drive phase, where we actually use our biggest muscle group, which is then a shame because we give a lot of good work away due to the wrong technique of coming towards the catch, or the limitations they are in due to maybe the not ideal catch stretcher setup. Vice versa, we see the same also at the finish. So, aiming for a strong finish position requires that our pelvis just past the neutral position, that we sit up properly and have sort of a strong handle height to be able to sit into that position we need to understand how we can engage our glutes to sit up there. But what we often see at beginners and also a lot of rowers is that for them the concept to, you know, keep the glutes engaged while coming towards the release point ends up often in a visual picture like that, where the hips drop down and then we reach a weak finish where they move towards a finish angle, but the loss of their force throughout the last third or quarter of the drive phase can often be quite massively. Yeah, and this is also then a hard posture to get out on and stay in time with the other crew members. So again, summarizing our rigging topic from today, I guess the last question we sort of have to ask ourselves is how ideal is your current rigging setup? Yeah, and you can check that yourself. So there are two types of the assessments, and I'm sure you do that anyway. One is that you check your rigging technically during your training sessions, and you want to check your rigging preferably prior to competition. So technically, I would always recommend that we check sort of the rigging during training sessions where we also do different stroke rate pieces, because if technique looks good at the low rate, it doesn't mean that our athletes are capable of taking their technique skill into the higher stroke rates. And if that is an issue, we sort of have to check if this is a technical component or one that relates to to the rigging setup. Vice versa with the racing. Obviously, for that point, that's where we want to have the rigging set up perfectly. And here, I would always recommend you have to find ways that you can put your crews into racing simulations and into pieces where they can try out the rigging. Also maybe slightly within the conditions you are expecting for the course you are racing, because we do want to understand if, for example, the crew, how can it hold the speed at the same stroke rate? Can they increase speed as a crew when the rating goes up? If that doesn't happen, we have to check if it's a rigging issue, if it's a technical issue. So you do need to check your rig, not just technically, but also for your actually aim of the rowing sport. And this is for racing situations at long distances from 2 kilometers or longer, or then if we look into the junior and master programs, then into the shorter 1 kilometer distances. So the picture underneath again shows you that rigging is a very complex topic. People love to talk about it. You spend a lot of time in setting up the boats for your athletes, always with the aim to find more speed. But more speed can only come if we find the best possible setup for the individual, so your individual motors within the boat that are required to propel the hull towards the finish line. So I hope that Gianni and I could give you a few ideas of how rigging could be looked at. We hope you got a bit out of that rigging session today, And we look very much forward to hopefully finally see each other back at the racing courses next year. We wish you all a Merry Christmas, stay safe, and enjoy to keep coaching at your clubs, at the universities, schools, or with your national team. Thank you very much.
Everybody, and now we have seen this very nice presentation of Conny that as usual she is doing very well, and of course all presentation they request some questions, not clarification because I understood quite a lot, but some points that maybe some coaches would like to have more information about it. One is the method that you suggest to set up the angles in the boat are very important, but and very useful. But you have two kind of measurement of these arcs. One is you call it a spread distance method, and another one you call it the reach the distance method. So can you tell us why you put two of this kind of measurement? And what is more easy for coaches to do it to avoid mistakes, because I know it's quite complicated. Please.
I introduced both methods because I think both methods are used in the in the practice of rowing to set up boats. And so when you look through the internet, there are quite a lot of rigging tables out there. So it's quite important that when coaches want to use, these type of methods to set up their boats, it's very important that they understand which table relates to which method, so they set their boats up properly. I guess the spread distance method is a more simple method and more sort of widely used by coaches, because with the tools we commonly use, in our rowing shed and, out on the water, it's easier for us to set it up with a ruler, with some string. So it's a bit simpler. With the other one, you would definitely, to be very accurate, you would need two rulers, and that would be not so easy to hold them steadily and evenly on the boat.
Good. And I have one one question about how, when we change the gear and we give the gear to the athletes, especially in the clubs, the coaches, they give more or less the same gear to everybody. But do you think that a better gear can avoid the mistakes for the future? Because rowers with the not right rigging on them, they can have a problem of transferring the power, or to be longer, especially when they are tall and not so strong. Can we give some practical suggestions to the coaches what to do to make one average rigging, and eventually suggest the athletes, for example, to put the collar, one extra collar to make lighter, shorter the inboard or longer the inboard? Can we give practical suggestions to teach better technique without big loads?
Mm-hmm. I definitely think that we can assist our athletes better from the beginning of their rowing career, or when they start rowing and enjoy that movement, that the more or the better they are set up in the boat, of course, the easier it is for them to learn the right technique. We can see, especially with novice rowers and athletes coming through the pathway programs and still growing, that there are quite a lot of issues we sort of often forget. And this is that with young men who grow quickly, they have a lot of mobility issues. So for them, it's very important that we sometimes maybe give them a little bit of a different stretcher setup, to make sure they learn the rock over easier, because they would be quite tight in their hips and ankles. Vice versa with the women, with the young women. I think it's important that we always keep in mind that they have a much lower strength level, and especially their upper body is, much weaker than to the men. So to learn the technique and that sequencing properly, legs and then upper body, arms, I think it's highly important that we don't overload young women, because we can actually achieve more with good sequencing than we can do with high loads. Because the problem will be that during just during one training session, they could actually lose a lot of their technique by just fatiguing much quicker and trying to get out of that fatigue. Yeah, they go into sort of different postures just to be able to finish the session. So I think it is important that we make sure that we overthink a little bit what rig we want to use, even though it is logistically not easy in big clubs, yeah, and schools. That's totally understood. But I think coaches can do something to make sure that the athletes are set up a little better. But I think also our athletes have the responsibility to make sure that they set up their foot stretcher before they start rowing. That's something they can control. And I think we need to get to that point that athletes use the right shoe size while they are rowing. Again, it's a logistical issue, we know that, but I see it too often that sometimes athletes use big shoes and the shoe is 6 sizes too big for their feet. I mean, when that happens, then the coach can set up the boat as well as he can, but the entire stretcher system is already failing straight away, because that person who was supposed to sit up here slips right down. So the whole setup is then wrong for that person. Yeah.
And you can suggest some tricks to compensate this? I am thinking, for example, to put some some rubber down in the shoes to avoid that the shoes they go too much down. Little tricks that we can teach the coaches to repair something that we cannot say put different shoes every time, because it's more with the system they should spend 15 minutes only to change the shoes. So and the time up for the school is very tight. Which tricks they could do it?
I guess your trick wasn't too bad. I think also knowing the position where you need to be in, that's something the athlete can change quickly. That's already one little trick. I like the one of yours, putting something into the shoe. That definitely will help. I guess, with that little washers, athletes are can very well adjust their height of the gates. That works really quickly. I just think athletes need to be aware what setup the coach wants them to be in, and then they can make this height change, and then also with the shoes change quite quickly.
Sometimes also this can be a suggestion for athletes too, to make it a little bit easier. Some clubs on also national team, they don't have the change for the height so easily, so they have the blocked one. So another suggestion for the height can be that the boat is rigged for the tall athletes, and the short athletes can put a pillow under the seat. So big pillow that they can compensate what you cannot really change. So the pillow higher, the rubber under the shoes, this can give some kind of help. And also for change the angle, you can put some plastic rubber again under the shoes with some tape, and then you change also the angle. Some small easy things that you can put it in a short time, and the athlete says the boat more for him without making big rigging all the time.
Yeah, we know that there are new solutions coming out, so it will get easier in the next few years to do that.
There
But
are
for right now, I think, yeah, I
there
think
are
awareness and
there are on the market also some shoes that you can change it going up and down. I think this is very practical, not for national team, because national team is something different, but for clubs, they can be useful because they can make short shoes, longer shoes, just changing like on the ergometer. So it's quite easy. Good. I have a last question. Last question, and is this. Of course, with biomechanical support that you and some other very good biomechanicals, we can understand a lot about the right gear of the athletes and how to do better. But the coaches that they have not this luxury and they want to improve, can we change, can we teach them to do something and to understand if the rigging is good? You explained that the rigging should be for the technique and for competition. Can you give some more indication that the coach knows what to observe and which parameters he needs to understand if the rigging is correct?
Mm-hmm. Okay, so I guess we talk so much about rigging to set up our athletes well, and obviously we get a lot asked, is my rig correct or should I change something slightly? I guess if we want to understand if the rig works for my crew and for my athlete, then technically we need to understand, is that rig working at different stroke rates? So if it looks good at 20 over a longer distance, we still need to understand how my athlete is coping with that rig when the rating goes up. This is, so it's important thing that we see it over distance and over rate. So we cannot just sort of assess rigging on 15 strokes. That would be a little bit, it would look better than what it, actually could show us over a longer period of a training session. I guess when we come to when we want to understand if the rigging is good enough for going into racing, I think we need to put our athletes into this racing condition prior to the regattas. So where they do, again, longer pieces on mid-rate and also some starts and maybe also try some, sort of some finishes. So that we actually understand if they cope with that rig once they put themselves under racing or racing simulation practice. And then where we will see, the biggest measure and key parameter for all of us will be how is the speed going with the rate. I mean, that's the best point to actually see if the rig works. Individually, obviously, we also want to check, is the crew rowing? So do they start to row shorter, which they are going to do once the rate goes up, but are they going to row too short? Are they still efficient? This is something where you can use your eye to check that. Yeah? But I guess the most important one is to prepare the racing is use your stopwatch and check it against the stroke rate.
Good. Now that you are talking, I have the really last question. How we, especially the younger athletes, they don't have the right posture. So they make big curve, they turn back the pelvis, and we see that we don't like the back, but we don't know how to do it. Can we help them with the rigging? Because the first point is the coaches, they put lower the rigging because they are going lower with back. Is this the right solution? Or we should ask to do something else? I like your proposal of changing the foot stretcher because the foot stretcher can work a lot on the posture of the athletes. Do you have other things to say or give a suggestion to coaches how to improve the posture of rowers in the boat?
This is a topic I love to sort of discuss a lot with coaches because I think this is often the course where we can assist our athletes to get better. It's to make them aware what posture they are in and what posture they need to have to be able to initiate, for example, the force straight from the moment the catch starts. The problem is often that we overuse the word power, but do not actually make sure that we use the recovery phase to make the athletes aware that the recovery phase is the preparation for our drive phase. So in the recovery phase, this is where we can control the posture we need to have once we are moving towards the catch. If my athlete is not capable of reaching at sort of that tall posture and sort of the vertical legs, so they can properly push off, properly horizontally push off the stretcher, then we often need to change a little bit and help them. So what I often do with coaches, and I like to do that, of course, in a discussion, that we ask the athletes to go towards the catch, and then we check in that position if there is a limitation. It could be mobility, it could be just the sequencing coming towards the catch. What we often need to also teach our athletes is, how would it feel if you push properly off the stretcher? So with a proper technique, with a proper posture at that catch position. Sometimes for athletes to realize what they need to do, I sometimes suggest to move the feet down so they have a little bit more room, so they can actually practice a little bit what the coach is trying to teach them, so they can actually move the legs before they open the body. And when they do that and realize how it goes, then, you know, the back muscles also start to realize how your movement is needing to change. So you practice that a little bit with a slightly different rig, and then you can go back up once, you know, you had enough practice with that sort of adjusted foot stretcher setting. That seems to help quite a bit, that we sometimes make it a little bit easier for the athlete during training, just so they understand the sequence we are after. So it helps us with a better sequence, but it also helps the athlete to get more mobility while sitting in the boat.
Thank you very much. So we can close here, or your questions for me?
Always have a question for you. It's always fantastic when I'm able to work with you and with your teams, that I love to see how you set up boats with athletes where they don't have the same, you know, sort of height or arms and leg lengths, because it's always fascinating that you make fast boats, even though the athletes who are in the boats, you know, obviously look quite different, because often smaller countries do not have access to so many athletes at that high level. So what is sort of that secret in setting up especially doubles when the leg and arm lengths and sort of shoulder widths, it's quite different?
I like this question because the people, they think that just because athletes, they make results is easy. In reality, it's not like this, for two reasons. First, in the small countries, usually we have two athletes to make the boat. So or you make the boat or you don't make the boat. The other solution is or the single or the double with two big difference roles. So my, we say secret, but it's not a secret, is to put in condition the athletes, smaller athletes, to help the bigger athletes, because it's very easy that all load is on the tallest one, because he has the wide arc and he has the more load generally, And the small one always is in difficulties to rush behind him. Is finishing before the recovery, is finishing before the finish, is not really able to sustain him in the right way, or her in the right way, because I have the same problem also with the tall, with men. So one point that I focus a lot is what I can do to increase the arc and for the small athletes. And when I increase the arc, I should increase the arc, but not increase excessively the load of these athletes, because usually the small athletes are also weaker than the tall athletes. So I must only put these athletes in condition to pull together, be in timing in the catch and timing in the finish, and give them this opportunity. The opportunity is, of course, reducing the spread, much less spread, give the right spread for the right inboard for the spread, and at the same time make all adjustments on the foot stretcher, because for me the key point of rowing, it looks very stupid, but it's not like this, is the foot stretcher, the secret of rowing. Because if we act well on the foot stretcher, we can gain more mobility at the catch. As well, we can help the athletes to make a better pressure in the finish, because the right angle of foot stretcher is not important to reach longer catch, but it's also important to make a very good pressure at the end of the stroke. So these adjustments, they make a kind of give more angle to the athletes, because to move only the spread is not enough. We should change 5, 6, 7 centimeters to compensate 15 or 16 or 20 centimeters of difference. So this is not possible only with the spread. We should have some other issues to put together, but at the end, as I said at the beginning, I just put in condition the small athletes to fill the boat together with other. Because what is important for me is that they have the same rotation speed, the omega speed, that they must be able to give the same speed when they pull, so they have the pressure. It doesn't matter if one is stronger and another one is weaker, but they must be able to be in pressure together from the catch to the finish as much as possible. And this is the method I have. And until now, it works well. Of course, the athletes, they must believe in what they are doing. But I am lucky. I find always intelligent rowers.
That's good. And one other question I like to bring up. I think we all notice that we are facing sort of an interesting time sort of with our rowers. They get, you know, better off-water strength training. So we get quite strong athletes, but sometimes it comes with the limitation that we lose mobility with these athletes. What is the right ratio you think we should be aware of? Because we don't want to really give length away. We actually want to use, you know, dynamic power, so use strength, but we want to use the speed, you know, of the handle velocity and you know, short the drive time to actually make it possible to get the boat speed going. But I see that we really suffer on stroke length sometimes when we have, you know, quite strong athletes who have a problem to compress properly coming towards the catch. We lose quite a bit of the actual leg drives they train for in the gym.
I think first, this is one mistake that we have in rowing, and we should also change the mentality about it. First of all, I think in rowing we need to be strong, but not very, very, very strong. Exceptionally, there are some parameters when the athletes they reach these parameters, they can stop to increase their power, their strength. But if we observe the weightlifting athletes, in reality they are not so stiff. I have seen some squat of snatch athletes that they put up 250 kilos, but their flexibility in the knees is something exceptional. I've never seen it. Also in the shoulders, they have huge muscles, but they can go with the weights, with so big weight behind their head. So in reality, I think it's our rowers, they are making mistakes. They don't do enough stretching when they make weightlifting. They don't have the right technique when they make the weightlifting. So I think always that the athletes should be stronger, but their capacity should be transfer this more strength that they build in gym to have more speed in the boat. So in reality, I would like to say, if you are stronger, but you must be stronger, not because in the boat you must move the weight that you have in the gym. You must be only faster to move the weight that you have in the boat. So just to make one very easy example, if I have one athlete, he has a 100 kilo of weight of squat. These athletes with 100 kilo, if he must pull 30 kilos, because usually this is the percentage of load in the boat, 30, 35 kilos if in single, these athletes has 35% of his strength. But if with these athletes is able to make 150 kilos, 30 kilos is exactly 1/5 of his maximum power. So it's a very small percentage. So he can express much higher speed and he can go faster in the boat, but not stronger in the boat. So for me is stronger to be fast and not stronger to be strong. Because if you want to be strong in the boat, you don't get speed, but you get brake. Because to be strong, you need to slow down. You cannot go fast when you want to be strong. So we must have this, I have this concept with my training, that athletes, they must be strong, but then they must convert this strength in speed, not maintaining only for strength.
Thank you.
Do you have more questions? Okay, don't tell more because I think our presentation is too long. So I want to thank you very much, Conny, and I think you are very well known worldwide for your very intelligent and very practical suggestion that you have with the coaches all over the world, and not only national team, because I know that you work also with the university, with the clubs. So your way of supporting people is very, very wide. And the people, they recognize you that you don't have only information to share, but you have mostly experience to share with your people that you are helping. So I am very thankful, and also this evening you confirm your great experience in rowing, and I want to thank you for this very good explanation you have done to us with the biomechanic, and also the questions to me are really competent questions. Thank you very much, and thank you to all coaches that are watching us today. Thank you. Bye-bye.
Good evening, everybody, and thank you for joining to me today to speak about the physiology tests which are practiced to our athletes in Tunisia. Thanks to ordering, and in particularity Gianni for inviting us to take part in this coach conference. I will give an overview about our plan in our presentation. Performance model, definition of testing, aims of testing, testing model used by Tunisia team, how and when we test, interpretation of our results and practical recommendation, conclusion. The sport event is based on the assessment of the individual to improve performance. The performance model or success model according to Weining 1983, which is easy to interpret, representative and presenting the factors responsible for sports performance. So sports performance is an enormously complex multifactorial phenomenon, morphology, psychology, technique, and physiology, as well as the interaction between them. All the coaches in the world need the best performance, but without clear understanding of which factors influence performance, it will be difficult to sustain success. I will show now the motto of the Olympic Games is made up of 3 Latin words: Situs, Altus, Fortus, which means faster, higher, stronger. This motto is a sentence which sums up a philosophy of life or a code of conduct. Was proposed by Baron Pierre de Coubertin. It's a clarion call to all competitors, including the youngest, to engage in training strategies that prepare athletes to be the best in the world. To prepare athletes and to achieve their goals, we need a test, and according to Pampa 1999, a test requires performance by the individual. Evaluation refers to the process of determining the status of the person relative to a standard. So, evaluation or tests help coach to determine what works well and what could be improved in a program or initiative. We can test athletes in the laboratory test, and this test is a test as a requirement for athlete monitoring, and the aim to provide very detailed physiological information of the rowers, sub-maximal capacity and efficiency, as well as measure maximum performance parameters as accurately as possible. This information from the laboratory protocol gives a very accurate picture on the training and performance status of the rower, but it's not conducive to measurement on a large group of individuals on a regular. For this season, we believe it's important to introduce a battery of ergometer measurement that address the limitation of current laboratory protocol. Why we do a test? Testing helps athletes to measure and review a progress and develop a program to suit. And this way, testing identifying the strengths and weakness of the athlete in relation to his own discipline by providing indication on the specific needs of an individualized training program. This testing will provide coach a greater understanding of each individual's fitness trait and how they change through a training cycle as be able to accurately measure the net effect of shorter training cycle. The purpose of this evaluation to assess the level of physiological variables which are brought into play during the exercise. And according Leisure al. 1982, the evaluation of physical qualities also makes it possible to compare and select athletes and then to dose and plan training according to their current capacity. There is no training without evaluation. When we test, the battery of ergometer measurement will be completed by all aspiring juniors, under 23 and senior athletes through the domestic and international season. It's the same as the development protocol of the world rowing. The ergometer test protocol, which will continue to be conducted a minimum of 2 times during the preparation season. For example, I give our example in Tunisia. In Tunisia, we do 3 times during the preparation session. The first time is in the first week of October. The second time is in the first week of November. And the third time is in the second week of December and completed with one occurring near the end of the January. That there is 5 weeks between each test. To do a test, we need simple equipment and we must check it before the test. What are these equipment? Is a Concept 2 or rowing machine with PM3, PM4 or PM5 screen, heart rate monitor and stopwatch. Each category has specific distances to be performed by the development test protocol based on their training level. As we see on the screen, distances are same for each category, only for high performance level, they do 50,000 meters. And for under 19, they do 10,000 meters. And for under 16, they do only 6,000 meters. Athlete or coach must adjust the ergometer drag factor to that appropriate to the category. For example, here we see on the table, for open senior men, they must to appropriate the drag factor in 135, lightweight men and junior 125, open senior woman 120, and lightweight woman and junior 110. We do these tests for our athletes till 2 days. In the first day, they do warm-up 150 meters max, active recovery, and 2,000 meters max, and anaerobic regeneration, light rowing or light cycling or light running 40 minutes. And afternoon, they do warm-up 6K at rate 24, aerobic regeneration light rowing 40 minutes. And in the second day, they do a warm-up 10 minutes, 50 kilometers at rates 2022 only for high-performance rowers, and 10 kilometers at rates 2022 only for junior rowers. And each athlete will be allowed to individualize their warm-up prior to each ergometer measurement, but are asked to replicate as closely as possible the same specific warm-up adopted for each distance. The order of this protocol should be completed before each test. The coach should wait and take anthropometric measurements, attach a heart rate monitor for each athlete, adjust the drag factor to that appropriate to each category, individual warm-up, select the appropriate distance on the test day, start rowing when instructed by the coach. Athletes will be required to produce maximum effort over all tests a number of times each season. At the end of the test, the coach will record the relevant data. In this, I will show this template. It's a monitoring assessment test template. And the coach used this template to conserve the data from these ergometer tests, provide highly useful information on the power per time data of each individual rower, which can be used to infer change in anaerobic capacity and maximal aerobic power, as well as show direct changes in 150 meters, 2,000 metric meters, 6,000 meters, and 50,000 meters ergometer performance. So the group data can be used by each coach to objectively assess the effectiveness of their training cycle since the last series of tests. Now I will turn it over to my colleague Sabhi to continue to the second part of our presentation.
Thank you, Ibtissem. Now we start to discuss how to use and analyze the result of this protocol. This test protocol aims to give you a sample and effective tools that can help you to monitor and adapt your training program. As we know, performance over 2,000 meters is dependent upon the functional and capacity of both the aerobic and anaerobic energy with different percentage. And this graph shows that the shape of the curve changes from one test to another, explained by improving some quality and lowering of other. The evolution of the result test can provide detailed physiological information of the rower. Improvement or regression from one test to another give the coach the possibility of adapting his program individually. Now we start with our first test used in Tunisia. 150 meter all out and do it in 30 seconds average. That means we evaluate with this test the anaerobic and lactic quality. We observe no improvement between the first and the second test explained by we are in preparation period and we recognize the aerobic slowly training. And after we see some improvement during all the other tests. The second test is 2K test, known by all coaches, is the simulation of the real computation. So this test is an indicator of performance. The performance in this test depends by several physiological factors: power, VO2 max, blood lactate concentration, and pacing strategy developed by rower in this test. And we see some improvement in the third test and in general. And this is confirmed by many articles scientific. So when we do this test, we assess all these parameters. The third test we do it in Tunisia. It is 6K test at 24 stroke. The duration of this test is between 18 and 24 minutes. It depends on the level, gender, and the category of the rower. During the season, when we do the 6,000 meter, we can see some improvement or disimprovement. It depends by our training program. And rowing ergometer performance over 6,000 meters in international competitive rower is mainly determined by power output corresponding to the ventilator threshold. The give, and this is confirmed by Pavel Mikulich. And we can see here in the green part there is a correlation between the performance in 6,000 meters and the ventilatory threshold. This test gives us information for each rower about her anaerobic threshold. And it's very important to know this quality if you want to be very precise when we prescription a training program. The last test we do in Tunisia is 15,000 meters at 22 stroke. The duration of this test is 56 to 66 minutes, and we assess the endurance quality. Endurance participate in the competition with 75 to 80%, which explains the importance of this quality. The more we have a higher endurance capacity or quality, the more we have a higher density of mitochondria, higher enzyme activity, and higher oxidative capacity. Therefore, endurance training form take the main part of the training schedule. Also, it's also necessary to evaluate the interaction between all these parameters and try to develop a physiological profile. When we see this curve of the evolution of this physiological quality during the test, we can remark the 150 meters have a huge impact in 2,000 meter performance, and this is confirmed by this article when we use 30 seconds to predict 2,000 meter under rowing performance. Physiology profile identify the strength and weakness of each quality for each rower. This test gives us hopefully clear how a regular measurement or ergometer performance of our rower can guide and individualize training program and well as assist with evaluation of the success of a specific training block. Also, the result of this test could use it to make your national training program uniform. The last parameter we can take it from this protocol of test is the critical speed. The critical speed or the critical velocity has been used as a practical method to predict maximum average velocity in variety of sports. The critical power concept might estimate the anaerobic threshold power, something you otherwise only can do it with the VO2max step test. We can use the critical speed test as mean of predicted 2000 meter rowing ergometer performance. And also here we can see it's confirmed by scientific article. And the last conclusion, we have to conclude here, quite simply, the test battery does a sample strength weakness assessed across the specific fitness trait required by rower without need to undertake laboratory tests or time out from the routine training environment. Also, in this COVID-19 pandemic, these tests are less risky than to put mask in the face of rower or having invasive method to measure the light depth. In the meantime, a rower can use this standard to determine the best training for their performance goals. Also, to produce and select world-class rower, it's not necessary to use expensive and complicated equipment. This test can affect a larger number of rowers at the same time. This test also is very closer to training and competition conditions, are more valuable than other tests. And the last, how I said in the first, it's the aim is to give you a sample tools to monitor and adapt your training program. Before I finish, I want to say many thanks to Gianni Postiglione, World Rowing Coach Director, to Fayçal Soula, our Tunisian National Technical Director, to our two colleagues, Chakri Ben Milad and Mohamed Mhenni, the National Tunisian Coach. And thank you. Shukran.
Welcome, Ibtissem. Welcome, Sabhi, Fayçal, and Gianni.
Thank you.
We saw your presentation. Thank you very much. And I think it's a good time to have a few questions about that. And I'd like to introduce Fayçal too, because he is also working with you to make the Tunisian team better and better, but also organizing a lot of events in Africa and Arabic countries to improve rowing and develop rowers in Africa and in general. So, but my first question is to Gianni, because Gianni is also helping you to develop this program. And is this way of testing more like a signature methodology to become a successful team?
For sure is to teach rowers to train a little bit more aerobically, because between aerobic and anaerobic training is much easier to train anaerobic because it's short time, very intensive, and you can do it. But the difficulties, especially with development countries, to convince the athletes, but also coaches, that the volume of training of aerobic, for technical point of view and also physiological point of view, is important. So one of the key points is, are you able to row at least 1 hour? Because the distance of this test is around 1 hour. So are you able to row 1 hour? Because if you don't have this minimum level, you are not preparing well, especially if you want to make a polarized training, for example. So you make very intensive training and very low intensity. But low intensity, it means that in any case, you must pull. And you must pull at least for 1 hour. But if you are not able to row 1 hour, so your preparation is not enough good.
All right. Okay. Good. I saw also in the data that and this is a question for Sabhi, in the data that the 15K test is usually on a limited stroke rate of 22. Can you explain what the reason is for that?
Yeah, because I think to develop the best pacing strategy,
to be able to row 1 hour for 50 Ks.
Mm-hmm. Okay, but is the tendency to do a higher stroke rate or a lower stroke rate? So if you don't say anything to the rowers, if you don't say anything to the rowers, do they tend to go to a higher stroke rate or a lower stroke rate on this long test?
I think the test, they will be, it's average of the stroke rate, not, we don't need to be at 22, like it's average. He can go more faster in the start, and they can, after they have a rhythm, and after in the finish, to have a best performance, they can have more higher stroke rate in the finish. But I think when we see all the data we have in Tunisia, we have the average is 22.
All right. Okay, that's more a conclusion than an assignment for the rowers.
Yes, but when we said for the rower, we said try to be a 22 stroke rate. It's the best stroke rate to develop the best pacing strategy for 1 hour rowing.
All right, good. Okay, another question for Ibtissem. Well, when you describe the testing protocol, it seems to be very simple, but it's also a very compact protocol. So it's in 2 days, 4 sessions, 4 maximal sessions for different lengths. How do you manage to motivate the rowers to do this maximal sessions in only 2 days? How do they cope with it?
This protocol of test is it's a simple tools for development countries to track the athletes and know the strength and weakness to improve it. And we do it this test is in 2 days. Is not I know the athletes, they must to do their best, and they must to give all them powers on these tests to know the realist results. When we do those tests in 2 days is 150. It's and 2,000 meters maximal. In the morning and afternoon we do 6,000 meters. It's not they can do it, so we must to push them and to try to understand. They must to do their best to know and to know their own results to build the program and individualized training program.
All right. Okay. Yes, I know we do this testing also in the Netherlands, but usually we take a week for this, so that there's enough recuperation between tests, and then the rowers enter their results to the Rowing Federation. Would that be possible in Tunisia too? Is it necessary to do this in 2 days because of the motivation for the crews, or do you think it's also possible to do it on a bigger distance?
Yeah, the big distance, 50 kilometers, it's in the second day, and it's at rate 20. At rate 20, it's a like UT2 session. Mm-hmm. It's a quiet session, so they can do it, and like a session. It's not very, very hard. Right. What I want to say, I want to say something, but I forget it.
Can I say something?
Yeah. Also because it's we follow the protocol of development, world rowing development. So we try it this year, and we find that it's a good tool for our athletes, and we when even those results, we can change their program and to know which area are good and which area aren't good to perfect it and to individualize each athlete her own program.
Okay. Gianni, you wanted to say something about this?
Yeah.
Hani, can I say something? Okay, Gianni, okay.
No, Sabhi, tell.
Yeah. To motivate some rower in Tunisia, we can do some challenge between the rower and between the rowers themselves also, and also for it's. I know it's very hard to do this test in 2 days, but when we do this test, it's the beginner of the microcycle. That's mean we have 1 week light training, and after we do this test, and I think in the beginner if you make a cycle, and after 5 weeks to work, and it's like a challenge competition between the rower, between many rower, and between the rower and themselves.
Okay.
That makes sense?
Yes, it does, certainly, yes. Gianni?
Yeah, the reason why they make 22 strokes is because it's in 2 days. Because the stress, every training make a stress. Also, one test make it a stress, and the training too make it stress. So in reality, the stress day is the first day with 2000, with high production of lactate and big effort, high velocity, a lot of power, as you have seen it. Now, the day after, of course, it's 15 kilometers, 1 hour with good intensity, but the stress level is much lower. I made one. I have one concept that the stress is in proportion of the distance of the training. So longer distance it is, less psychological stress you have. Mm-hmm. The highest psychological stress is with the 2,000 meters. Yeah. So we have some competition like a World Cup. We have 3 tough races in 3 days or in 2 days. So the athletes, they should be able to recharge the psychological batteries quite fast between one race and another race. So these tests prepare for this kind of psychology, because in reality it's psychological, it's not it's physiological, but if they are trained, they should be able to do it. Yeah. So we have 22 strokes, not so high, but they must recharge their motivation for the test on long distance. So higher is possible, but you must be really very well fit. Right. The 6,000 meters is an aerobic threshold. Lactate is not so high; it should be around 4 or 5 millimole. And then there is maximum test with the 2 kilometers. That one is the real tough one. But for the other, the last 2, you must be only trained. If you are not trained, you cannot do it. So this is the principle: is physiology and psychology at the same time in this so compressed test.
Okay. And a question for Fayçal. You have a good view on other African countries. Is this protocol also used in other countries?
I think for my opinion, we started with the test last. This kind of test is from the end of the last year, and but with COVID, we had some problem to continue and to have a good, let's say, reference to compare one test to other from each period. Is not the test to compare athlete to athlete. Mm-hmm. And this it's a good let's say landmark. I don't think, and for the athletes to know where they are. It's good to know where they are from microcycle to microcycle. And with these simple tools, I think some countries like Algeria, Egypt, I think some clubs are done. I don't know if the national team use this, but we push them to do it. Libya, and I think they start to use this test, and it is, let's say, it's the test motivate them to work and to compare their work. Maybe it's not very, it's never very, the result is very right, but let's say it's to compare the period to the period, the progression, it's good.
Good. Okay.
We cannot replace the laboratory test, but it's good for motivation with the sample tools they have in development country like Benin, Togo. They start to use it, and it's simple to explain them. It's very simple.
Yeah. All right.
That's my opinion about this. I don't know. I'm sure we started now to use it in the end of the recovery. But week. But we can. I don't know. Gianni can give some opinion about this. At the end, now we use it in the end of the recovery week, but we can use it in the start of the microcycle. I don't know. What do you think, Gianni, about this?
Oh, you can do it because you can. All things are important when they are made systematically. If you decide to do it at the end of the lower load week, it's very good because you have the load, some break, and then they have the test. The tests say in quite good condition, physical condition, how they are. Of course, if you try also at the beginning of the training camp or immediately after when you want to start to reload the athletes, it's important that we have a system. So this system that you want to do is perfect. It works very well. And but others, they can choose a different way. For example, for some coaches can be a tough start for one period. So I want to increase the load for one week and I start with the test. So psychologically, they must be fighting with the test and then they must continue until the end of the week. So it can be one very heavy week, not light. So it depends how you want to use it. And the flexibility is in the hands of the coaches. But at the end, you must be always constant with all three, because at the end, there are only three of these tests. You must always use the same criteria to repeat it. Yeah. So I think you're doing well. Really good.
In my opinion, it's very important to do this test in the same protocol, that don't make a mistake. You use the same material, same instrument, and same thing. Because if you change, maybe the results will change. Yeah. And if you establish this culture of testing, it's very important, because some development country don't know what does it mean, this test. Yeah. They cannot compare themselves now with the COVID. They don't have races. They don't. But it's very important to have this challenge, and this psychology is very important to have the challenge every microcycle, every month. Yeah. Let's say we don't take risk before the races, but it's important to have these results. And you know, Hank, a lot of development country on Africa, they don't make the 10 or 15K. They can't directly make the races. No, I don't talk about Tunisia, but they row every day. But for the other country, we need these results. I think Gianni think about this, and we want some results from the development country to have the database. It's important to have this database from each country, and they come to the World Championship. If you ask them, what do you do at home? They say, we never go. We never done 15K in one session. It's strange. It's not normal.
Right. Okay.
If you establish this tradition, this culture is very important. Rowing is a long distance. You have to row. Yes. Yeah. You know that.
Yeah. Okay. Ibtissem, you wanted to say something?
Yeah, I want to add something. I want to say this protocol of tests. It's very important, like tools for development country, who they train. Not all of them, but I speak about the countries who they train usually, and they have a good level of rowers. So it's a good tool to follow their athletes and to know athletes about physiology. Also because in Africa, yeah, the test laboratory, it's expensive, and not we can't do it for we don't conduct it to measure a larger group of individual. So it's a good tool to use this protocol.
All right. And what do you think is the biggest challenge to organize a test like this for a group of rowers?
No, it's not. Maybe for some country, for example, in Tunisia, we have ergs, and we have each coach has a chronostroke, and we have a heart rate monitor. So it's not difficult for us, but maybe for some country here in Africa, in our continent, maybe they find difficult or challenge to do this test. Is maybe they don't understand it well, the protocol, maybe they don't have equipment, maybe they don't train well, or they can't do this test. It depends the situation.
Okay, good. Thank you very much.
Hank, I think, for my opinion, I think is now with the devices, you know, now we have a lot of devices for heart rates. I think with some phone, with some smartphone, you can. Let's say it's difficult now for rowing, but I think the biggest problem is the Polar to have the heart rate monitor. But for the rest, but of course they can get the Concept 2 PM5 now with the belt. You can have the heart rate, and you can follow them. But you know, we have access to the laboratory 2 times a year with our sport ministry. They finance us and they pay for us. But we cannot control each week or each month. We don't have budget for lactate and for. We know that's this protocol, but we can do it. We can do it. We do it. We do it when we are with the Thor Nielsen and CV, with some scientists. And we return back at home with the results, with the curve, your zone, everything. What we can do with this? It's not possible to use it.
It's better to do some of the measurements, some of the data you can get a lot of times, so daily or weekly, instead of having a lot of data only once. That's less useful. So I think it's a good way of having people see progression and have an idea of the development of the whole team. One question for Sabhi.
Can I say something?
He has a question. He has a question.
Okay.
Yeah. Well, I was wondering. I suppose you record all the results. What kind of statistics, what kind of science do you do with this data? Is it something that you can show other countries that it's easier for them to understand what you get out of the data, besides the personal results, of course, but also in the bigger sense that you see, well, if you have this data, you can evolve your program, or you can do a little bit more than only improve your coaching. What's the main thing you get out of the data? For Sabhi.
The main thing, I think the zone, heart rate zone, and also if you have heart rate zone, you can prescribe your training program with some precise, and also we can know our anaerobic and lactic power. We can know anaerobic threshold with this test, and we have like Excel sheet, and we put all the zone with stroke rate, like 81, 82, anaerobic power, and we put this with heart rate, with stroke rate, and with average or of power with watt in erg, and we work with this sheet till 1 month, and after if we have change, if you have improvement, we change. If you have lowering, we change also, and we still monitor and adapt our training program till the competition period.
Okay, good. All right. Thank you very much. One last question, because we are almost out of time. Gianni, you usually have one last question.
Mostly I have the last word, not the last question.
I have remembered about this test.
Yes.
Hank,
Yes, go ahead.
Hank, from my side, as I want to help the African country. If we are open to share our results and our sheets and the assessment Excel sheets, and they can, if they like to test this material, this test, yeah, this protocol, why not? And we can create a database on Google Drive, and we collect all the results. And if Gianni has time to give opinion and to adjust the program, it's very important for us. Yeah. I don't know, Gianni, if you are open for this. I know you are very busy, but you are in the Olympic year. But let's say for the athlete who prepare to the Olympic Games for development country, we have 12 nations from Africa and single and double lightweight, and it's a good opportunity if they like, if the coach like to follow this kind of tests. It's very important for us, and we compare. We are open now. Everything is open. There is no secret now.
All right.
It's not a secret. Good. We are not a big country to make secrets. Is it good? Right. Yeah, of course.
Yes.
Okay.
But I don't know. It's a good opportunity for them, for the coaches, for national coaches in Africa or Latin America or in Asia or in Europe. Why not? And to combine, to collect all results, and we can create, we can adjust some results, and we can have good thing for everyone.
Okay,
it's good for us. Let's say let's give rowing not expensive.
Yes, very good.
That's
okay. A good idea. It's a good good invitation to other countries also. Very good.
Yeah, Hank, because we want to hang a medal, so we don't have a secret in Tunisia.
Oh. But if you're doing well, there's always some people who think, "What's the secret?" And now we know the secret. So you want to share, and that's very generous and very good. And I think we all can learn from it and do our best with it. Thank you very much. Okay, I'd like to thank you all for making this presentation and having this discussion. And I hope many people will contact you to share their knowledge and to ask how you work and share the results also. Okay, thank you very much.